So we're going to spend some time graphing these kind of functions. The graphs of these things are parabolas. There's several things that I'm going to want you to find. I'm going to want you to find the vertex, the x-intercepts. In this case, it's plural. The y-intercept, singular, and the axis of symmetry. And I want the equation of the axis of symmetry, not just a number. And on the test, I'll be careful to ask you for the equation for the axis of symmetry. But let's try and understand a few things about this form of the equation. Now, another form that you can see this equation in is y equals ax squared plus bx plus c. But I like it in this form much better because when you have it in this form, you can tell certain things about the graph. And so what I want to do is I want to try and figure out what the a, h, and k do for us in the equations that look like this. So let me cut over to Desmos, and we'll just kind of play around with things one parameter at a time and see what the effect is. So over to here. Let's start out with the a. Now I'm going to change a slowly from, say, -10 to 10. Well, let's go something a little bit less generous. -2.5 to 2.5. And we'll increase by an itty bitty bit. And let's see what happens when we run through different values. So try and figure out what the effect of changing a is going to do. So a affects what? Yeah, it affects how wide it opens or how narrow. And what other thing can a do, the value of a can do to the graph? Yeah, it can flip it, right? It can open down. So when do you suppose it would open down? Yeah, if it becomes a negative. So let me try and stop that up here a little ways. So let's go back to like a equal 1. Close enough. Yeah, close enough. And now let's take a look at h and see if we can't figure out what the value of h changes. So h is right here. And if we try and change h, what's h doing? Yeah, it's moving it along the horizontal axis, right? So the value of h affects things horizontally. Yeah, it changes things along the x-axis. And last but not least, what do you think k is going to do? Move it up and down along the y-axis. So, yay. Now to really mess with your mind, let's do all three at once. There we go. All right, just kidding on that one. Let's stop. There we go. Let's go back now and answer a couple questions here, starting with problem number 24. Oops. So f of x equals 2 times x minus 2 squared minus 1. Let's see what things we can determine about this. It asks you to determine whether this opens up or down and where's the vertex. Also the axis of symmetry, the equation of the axis of symmetry. So first things first, let's find whether or not this opens up or down. What do you think? Any thoughts out there? Yeah, it opens up. 2 is positive, so it opens up. Now I want to figure out the vertex. Now look, on an exam, the vertex is worth 2 points. And it should be some easy points. So let me make sure that you understand how to find the vertex. You're going to get the vertex when you put in a value of x that makes the squared term equal to 0. So what would I put in here to make the squared term equal to 0? 2 for x. Now let's do that. Let's do f of 2. 2 times 2 minus 2 squared minus 1. Now the y-coordinate of your vertex is what you get out of this. And you really shouldn't have to think too much on this. 2 minus 2 is 0. Squared is still 0. Times 2 is still 0. Minus 1. What's your shortcut on that? If you were looking at that equation and you didn't want to go through all this, what's the shortcut in finding the vertex? Yeah, it's just the value of k. Exactly. So your x-coordinate is what makes the squared term 0. Your y-coordinate of the vertex is k. So here, and then whatever value makes this 0. Nice. Let's actually look at this graph here on decimals. You could do likewise on your graphing calculator. I'm not going to take the time to do that. Let me shut this one off. Let's look at y equals 2 times x minus 2 squared. And then we'll, whoops, that didn't, 2x minus 2 squared. And then what else was it? It was minus 1. So here's your graph. But notice that a nice graph of a parabola is symmetric. So let's take a look here. We got x equals 2 is your equation of the axis of symmetry. So on either side of this graph, the graph is nice and symmetric. So you have a point, I don't know, point at 0, 7, and then if I move a distance over here, I should have a similar point right here at, again, 4 and 7. All right, that's close enough. But the equation of the axis of symmetry is something that I would want. Let's add it to our answer, and I think we're all done with problem 24. X equals 2. Now, as far as this is concerned, you could say, well, gee, I don't have a graphing calculator. You don't need a graphing calculator. Your axis of symmetry is always going to be the line that runs through your vertex. In this case, the vertical line is x equals 2. Let's do one more like that one, and then maybe start graphing a couple. Any thoughts on 24 before we take a look at problem 28 together? All right, so problem 28 is going to step it up a little bit. F of x is minus 3/2 times x plus 1/4 squared plus 7/8. Okay, first things first. Which way does it open? Down. This is negative, so it opens down. How about the vertex? Where's the vertex on this one? All right, so minus 1/4, and what else? 7/8. Good. So it's just whatever makes the squared term equal to 0, and then the value of k. How about somebody for the equation of the axis of symmetry? I'm not going to graph this one, but can you tell me what the equation of the axis of symmetry is? Yeah. All right, but be careful. Please don't just give me just negative 1/4. What equals negative 1/4? X equals negative 1/4. Now, the reason for that is because there's a big difference between x equals negative 1/4 and y equals negative 1/4. So if you did x equals, well, let's just do it with x equals 2 and y equals 2. X equals 2 is a vertical line, y equals 2 is a horizontal line. And I just want to make sure that you know the difference between your horizontal and vertical lines. Later in the course, we'll deal with parabolas that open sideways, and at that point, then you are going to have, y equals something for an axis of symmetry. But not right now. Right now, it's just going to be x equals something, plain and simple. Now, sometimes you're going to need to put these functions into that form. That's a process of completing the square. But let's practice some for which that process has already been done. So, has everyone got a handout? Let's take a look at problem number 32. So we're going to work on graphing f of x equals x plus 1 squared minus 2. So if you want to borrow a ruler, I've got some up here. Help yourself. I'm going to make myself a little t-table and keep track of some points. And allow myself a generous amount of space on my t-table. Let's start with the easiest point first. And that would be the vertex. At least I hope that's the easiest point. What's the vertex of this one? -1 and 2. Good. All right, so vertex is -1, 2. I need a couple other points. I need to find, for instance, the y-intercept.
Why would it be just 2 and not -2?
Oh, it is -2. Thank you. How would I find the y-intercept? No, that helps me find the vertex. How do you find the y-intercept of any graph, not just this graph? Set x equal to 0. So the y-intercept, you're going to set x equals 0. So it's going to be f of 0 is 0 plus 1 squared minus 2. What do we get? 0 and -1. All right. How about the y-intercepts? Or excuse me, the x-intercepts. How do I find the x-intercepts? All right, x-intercepts, set y equals 0. I don't really see a y in this problem. F of x is your y. So you're going to do 0 equals x plus 1 squared minus 2. Now, a lot of different ways to solve this one. What do you see? What occurs to you when you're trying to solve this one? Kyle, any ideas? How about if we ask instructor Ahmad Dhaka? Hey, Ahmad. Hey, Ahmad. Yella, come on. All right, whatever. He's blowing us off. He's just chicken. All right. Any ideas? How could we solve this one? Emily? Yeah, I think the fastest way is to add 2 and take the square root on both sides. So we get 2 equals x plus 1 squared. And then we'll take the square root. Now, when you take the square root, please take plus or minus a square root on the left-hand side. What's the square root of x plus 1 squared? X plus 1. Have I finished solving for x? No. What do I got to do? All right, let's take that 1 to the other side. And when I do, it goes over there as a -1. So I get -1 plus or minus a square root of 2. Let's put that on our table. Now give yourself some space though. There's 2 solutions here. There's -1 plus the square root of 2, and that goes along with y equals 0. Leave yourself some space here. And then -1 minus the square root of 2. So when x equals 0, there was 2 possibilities. -1 plus the square root of 2, -1 minus the square root of 2. Now, if I told you to graph -1 plus the square root of 2, would you know where to put the point? No, most of us wouldn't. So take out your calculators. What we're going to do is we're going to calculate the decimal value for both of these so that we know where to graph them. Okay? they should be both symmetrically located on either side of -1. Well, they are. You should see that, though, when you end up graphing this. On your calculator, remember there's that trick. Once you plug in the one solution, -1 plus the square root of 2, hit the second key, then the enter key. Just go back and make that a minus. And now you got both of them. Now, this is just for your benefit so that you know where to graph this. I'm not going to be taking out a magnifying glass and going, gee, Lisa, you only had 3 significant figures on your graph. No, just get it in the ballpark, all right? So to the nearest tenth is fine. So about 0.4 and about -2.4. And that's fine. That tells you roughly where to draw these points, and that's all we need. So let's look at our graph now. Let's put these points onto our graph. Let's start out with the ones that are easy and make sense. There's -1 and -2. That's down here. 0 and -1. That's on the x-axis or on the y-axis. And then we had points at about 0.4 and about -2.4. So looking carefully at this, each one of these, how much is each one of these worth? Each kind of tick mark here? About 0.1, right? So 2.4, -2.4 should be a little bit to the right of -2.5. All right. But like I said, I'm not trying to look at this with a magnifying glass. 0.4 should be a little bit to the left of 0.5. Oops. So we've got 4 points. And now it's just a matter of drawing a nice parabola. Your parabolas should be nice and smooth, especially at the vertex. So I'm going to pull this down for a second. And there. But notice those 4 points guide us to a pretty nice symmetric graph. By the way, let's throw in one other feature in here, one last feature, and that's the axis of symmetry. That's going to be this line here. I'm going to draw it with a dashed line just to remind you that it's not really part of the graph. That is kind of an important feature of parabolas. But the equation there is x equals -1. Nice. When I actually ask you for the roots here, you should put -1 plus the square root of 2 or -1 minus the square root of 2. But the decimal approximations we came up with were just to help us graph it. How are we looking on problem 32? Okay, first one, yeah, Emily? Just exactly what we did here. Exactly what we did here is what I'd like to see on an exam. Okay? You could plot more, but I don't feel that there's really any need to. It just seems like it's more work. This is good enough. That's all I'll be looking for. So just kind of a heads up, 4 points for the x-intercepts. So those are a big part of this problem. 2 points for the vertex, a point or 2 for the axis of symmetry, a point or 2 for this, and then a couple points for the shape overall. One thing that I do not want, I get this all the time though, is people drawing stuff like this. That's an absolute value graph. Give me something with a little bit of a contour to it, a nice shape there. Say again?
Where did you get the x equals -1 for the dash?
that's your axis of symmetry. It's always going to run through the x-coordinate of your vertex. So it's on either side of this that things are symmetric. And you can kind of see that here. And if you take a look at this distance, in fact, we got rulers here, right? Let's take a look at it here. So I got a little bit less than 2 inches from this point to the axis of symmetry. And then about same distance from here to here. So it's a double check of your work. If you get something that looks really lopsided, if you got a point like way out here, and then a point in closer, if it's looking lopsided just on a casual visual inspection, then go back and check it. It should not look lopsided.
So the axis of symmetry is always going to run through what?
The vertex. It's always going to run through the x-coordinate of the vertex. So even before we saw the graph, you could know that x equal -1 is your axis of symmetry, the equation of your axis of symmetry. Good questions. Thank you. Let's do problem 36-ish. All right. And you notice that there's an ish here, right? So that means basically I'm free to do whatever I want, just as long as I call it problem 36-ish. All right, so the change that I want to make is this. Let's write f of x is -2 times, where's x, x minus 2 squared. Let's make that instead of a -4, let's make it a +4. And that'll make a nice bit of difference here for us. As before, let's give ourselves a generously spaced t-table. The vertex. Where's the vertex? What one I called on you today? Right up front. What's the vertex here? All right, 4 is the y-coordinate. What's the x-coordinate? Not -2, +2. So you want to make the squared term equal to 0. That happens when x equals 2. And then the value of k is the y-coordinate of your vertex. So there's our vertex. There's a couple other points I need to find. Let's start with the y-intercept. Kyle, what should I do to find the y-intercept? All right, good. So set x equal to 0. F of 0 is going to be -2 times 0 minus 2 squared plus 4. And this should work out pretty good. So it's going to be -2 times -2 squared. And you got to be careful here. When you square -2, you're going to get a +4. But that doesn't change the -2 that's out in front. In fact, overall, what do I get for the y-intercept? Anyone? Should get -4. So 0 for x, -4 for y. What's different about these problems is that they don't work out with nice even roots for your x-intercepts. For my x-intercepts, basically we're going to set y equal to 0 or your f of x equal to 0. You're going to get 0 equals -2 times x minus 2 squared plus 4. There's a lot of ways you can solve this. You could square this out, distribute the -2, add 4, and then run through the quadratic formula. Yeah, it would take a long time. It'd be a real pain. I'd suggest you start by moving the 4 to the other side. Now, Emily did the last one. Someone else help me out on this one. What could you do next? Divide by negative 2. Good. So let's take both sides of this and divide by negative 2. Mark, you look attentive. So what do I get when I divide by negative 2? 2. Actually, that was the wrong thing to say. Because I don't want to give people the idea that they get negative feedback for looking attentive. All right, but we divided by negative 2. Now we got something that's a lot more workable. Bailey, what do I do next? Good. We'll take the square root on both sides. So I get plus or minus the square root of 2 equals x minus 2. And then I'll move the 2 to the left-hand side. When I move the negative 2 to the left-hand side, what do I get? Positive 2. Plus or minus the square root of 2 equals x. There's two possibilities here. 2 plus the square root of 2 and 2 minus the square root of 2. Again, you need to calculate these values for yourself on a calculator and just round it to the nearest tenth. Nearest tenth is quite accurate enough. First one I think should be about 3.4. You're getting numbers like this, about 3.4 and about 0.6. Now there's another clue in terms of did you get this right? And that other clue is the graph that I give you. The graphs that I give you will fit your parabola. If they don't, one of us is wrong. I'll let you guess as to who you think that is more likely. So, point at 2 and 4, that's up here. Point at 0 and negative 4, that's down here. Now, if I just drew those 2 points, and I know that this is my vertex at 2 and 4, what does that tell me about the direction my parabola has to open? It has to open down. And that's reflected right there, that I have a negative 2. So at least this much makes sense. As far as the rest of this is concerned, I've got points at about 0.6, which is here, and about 3.4, which is here. Yeah. And now it's just a matter of playing connect the dots again. Make sure you do so in a nice smooth way. I always kind of like to draw mine sideways so that I can get that curve in pretty good. Alright, so I need a new marker, but other than that, that doesn't look too bad. What's the equation of the axis of symmetry? Good, x equal 2. Runs nice vertical line straight through here. X equal 2. So that's 2 plus the square root of 2, 2 minus the square root of 2, and 0 negative 4. So I got everything nice and neatly labeled. So kind of revisiting, graphing these things again, except the only harder part about it is that the x-intercepts aren't nice and friendly points, and you're going to have to get used to that a little bit. Yeah, please.
On the exam, if we were to, like, when you put the points on there, if we were to put it as, like, for example, the 2 plus square root of 2,
Mm-hmm.
we
Well, on the exam, I'm going to give you a blank, and I'm going to ask for the x-intercepts, and I'll say, give me the exact values. So for the exact values, I'd want these numbers. Those are the ones you should put. But as far as graphing it for yourself, use the approximation. Now the thing is, your graphing calculator can give you a really good graph of this. It can give you 90% of the information that I'm asking. So if I put in my y equals key, -2 times, where was it? X minus 2 squared plus 4, and then I set up my window correctly, say -1 to 5 on the x-axis and -5 to 5 on the y-axis, I should get a pretty good graph. And it matches what I have here. But the other thing is that your calculator can tell me where these cross. If I do calculate 0, I can figure out, say, where that crosses the x-axis. There you go, 3.414. So the reason I want the exact values is because your calculator is not going to be able to give you that. But it gives you pretty much the rest. You can trace it at 0, find out the intercept, -4. That's all right. Go back and look at the video in slow-mo. Anything else on problem 36-ish? Let's try problem number 70. F of x is 3x squared minus 12x plus 12. And I think I might do something for you on problem number 70 just to kind of help out. Yeah, give me a second here. Well, there is a GCF there, but there's something more to this one. All right, so if I factor out the 3, that's x squared minus 4x plus 4. And can anyone tell me anything special about, yeah, thank you. You beat me to it. That's really x minus 2 squared. So it's convenient to have it in this form. Why? What's special about this form? What's better about this than this right up here? Can anyone tell me by looking at this up here, what are the coordinates of the vertex? No, don't know. How about down here? Can you tell me what the coordinates of the vertex are here? Good. You don't have to write the 0, but if you want to, maybe it's helpful. But the coordinates of the vertex are 2 and 0. So 2 and 0. So that's kind of interesting. It's right on the x-axis. So that also means that it's your x-intercept. Let's try and find the y-intercept. If I set x equal to 0, then I can find the y-intercept. Now let's be clever about this. It's getting towards the end of the day, and we want to try and get through these things as fast as we can. You can set x equal to 0 into either of a couple equations. You can set it into this one down here, or that one up here. Where is it easier to set x equal to 0? Top equation or the bottom equation? I'd say the top one. If I put in a 0 here, that term's a 0. That term's a 0. What's f of 0 going to be? Yeah, f of 0 is going to be 12. And you get the same thing down here. Just pointing something out. It's not something you have to worry about if you forget it. So 0 and 12. Now the x-intercept, if I set y, which is really f of x, I get 0 equals 3 times x minus 2 squared. How would you solve? Yeah, divide by 3. 0 equals x minus 2 squared. Then I take the square root on both sides. What's the square root of 0? So I get 0. Is there really any plus or minus to 0? No, it's just 0. So there's really only one solution, and that's x equal 2. Okay, well, we kind of already knew that. So there's not a lot we got to go on for this graph. We've got one x-intercept and a y-intercept. So we will do something to try and help ourselves out. But for the time being, we don't, like I said, we don't have a whole lot. So let's go with what we've got. So I got a 0 here at x equal 2. And at 0 and 12, that's going to be up here. I've got another point. Now, I haven't graphed a whole lot, but let me add in a feature that you should be able to figure out by now. Where is the axis of symmetry? What's its equation? X equal 2. And what I'm going to do is use the fact that this is a symmetric graph to kind of cheat. Not really cheat, but be clever. Because if I move 1, 2 to the left, I have a point up here. Is there a way to get kind of a freebie point out of that? If I move 2 to the right, over here at x equals 4, I should have a symmetric point. So that'll at least guide me a little bit if I was trying to draw a decent graph. But as far as the graph is concerned, that's really the only points that we're going to work with. So we'll play connect the dots and call it a day in problem 70. I think I was careful to say call it a day on problem 70, not call it a day. How are we looking on that one? Now, there's a couple other little things to mention in this section. Sometimes, for your problems, you'll need to do what we did here, and that is write this as a perfect square. So sometimes you need to do that process for yourself. Let's take a look at problem number 44. We're not going to have time for 74. I'll leave 74 for homework. In fact, let's see. For 74, you can try 74 at home. And let me help you out. 74 can be rewritten as 4 times x plus 1/2 squared minus 4. So you could also write that as, the original problem was 4x squared plus 4x minus 3. And maybe as my last problem today, I'll show you how to rewrite this like that. Let's start with a warm-up problem, though. We need to be able to change a form like this into a form like this so that we can figure out the vertex. Problem 48 is, no, problem 46, 44 is a good one to start with. F of x is x squared plus 6x plus 5. For convenience and for comfort, let's just write that as y equals x squared plus 6x plus 5. And what I want is I want to write it as a perfect square. I want to get it in the form a times x minus h squared plus k. So here's the trick. Let's move the 5 to the other side. And then complete the square over here. 5 to the other side changes that from positive to negative. Changes sides, it changes sides. Now do you remember how to complete the square? Good. 1/2 of 6 is 3. 3 squared is 9. So we're going to add 9 to both sides of the equation. So 9 here and 9 here. On the left-hand side, 9 minus 5 is 4. So this is y plus 4. And I don't need that extra parenthesis there. On the right-hand side of the equation, this is now a perfect square. What do I square to get that right-hand side? X plus 3. Last but not least, to put it in this form, I'm going to move the 4 to the right-hand side where it becomes a negative 4. And there you go. There's your equation in a different form, but an equivalent form. The nice thing here is you can read off the vertex. What's the vertex here? Rachel? -3 and -4. Good. All right, but the thing that I wanted to practice there was completing the square. So how are we doing on that one? Let me do one last one for the day. That's problem 46. And if you remind me next time, there's a vertex formula that I'll show you that you might find convenient. Now the difference about problem 46 is that you've got a coefficient in front of your x squared term. F of x equals 3x squared minus 12x. Excuse me, no, minus 12x plus 10. And like the last one, I'm going to write that with a y, just out of my convenience. I'll move to the 10 to the left-hand side to begin with. And I think we saw this with Abdulaziz's problem earlier. If you're going to complete the square, the coefficient of the x squared there needs to be 1. Now, the easiest way, I think, to deal with that is just to factor out the offending number. Don't factor out the x. You're not taking out the GCF. You're just getting rid of the coefficient. Let me factor out a 3. That leaves behind x squared minus 4x. Now that I got rid of that coefficient, let me complete the square on what's inside. So you can just ignore the 3 out in front. Let's work on the inside. See if you can't figure out what number to put right here. Don't worry about the left-hand side just yet. So it should be half of -4 is -2, and -2 squared is 4. So that 4 is what's going to go up here. but it'd be wrong to put a 4 on the left-hand side. Why? Well, really, by putting a 4 on the right-hand side in the parentheses, I haven't added just 4 to the right-hand side. I've added 3 times 4, which is 12. So that's that 3 times 4 is where this comes from. And that's where I get the 12. So that's the trickier part about this, is you've got to factor out that 3. When you do that, complete the square. 3 times 4 is 12. So that's why we added 12 to the left-hand side and not a 4. The right-hand side is a perfect square. It's x minus 2 squared. The left-hand side simplifies to y plus 2. The last step is to move that 2 to the right-hand side where it becomes negative. 3 times x minus 2 squared minus 2. And here you can read off both the x and y coordinates of the vertex. Negative 2 and negative 2 is your vertex. You can double check yourself on a calculator. You can look on your calculator and make sure that your vertex passes through negative 2, negative 2. So you can easily verify that. Questions or thoughts on 46? Yes?
So you only want us to use this for when you're asking us what's the vertex, not to graph it?
Probably what I'll do, and I really appreciate the question, is I'll ask you to put this into a times x minus h squared plus k form. So I'll ask you to write it like this. It'll just be a separate problem. And the reason I separate it is because a lot of times people, if I gave you this equation, people could graph it. No problem. They do really, really well. But maybe they stumble in coming up with that equation. And I don't want to punish you for not being able to do this part when you can do a whole lot more. So I make them 2 separate problems. One, I'll give you this and say, hey, graph it. Another one, I'll say, here's an equation, put it in this form. So that way you have a chance to show me what you know and not get hurt if you miss something or even if you make a mistake here. So I separate those two. Yeah, I really appreciate that question. That's a plus 2. I'm not sure where you saw a minus 2. Okay. Let's wrap it up here for homework. This is section 10.4. 23 through 29 and 31 through 37. Boy, that seems like an awful little. Let me go double check that. 31 through 37. You know, we are going to have to do a couple more problems, so I'm not going to assign some of the homework yet. You can try maybe 41 and 41 through 45. Do we have a test on Monday? My condolences. All right, so test on Monday will cover, let's see, section 9.7 through 10.4. Is that right? Because we covered 9.7 and 10.1 last time, right? So 9.7 through 10.4, exam 3. Awesome. All right, good luck. See ya.